So the application of Bernoulli's equation, we move on to pitot tube. So actually the pitot tube, what is the principle behind that is velocity of any point decreases, the pressure at that point increases. So where the velocity decreases at that point, the pressure increases due to conservation of kinetic energy and pressure energy. So the pressure and velocity or vice versa. So both are in an opposite sense. So, we can simply say the pitot tube consists of a glass tube bent at an angle. So what are the points we discussed in? It means pressure at section 1, pressure at section 2, and velocity at section 1, and velocity at section 2. Then depth of tube in the liquid, so capital H. So the rise in the liquid in the tube above the free surface. So that is the small h. Here specified point 2 is just at that fitted tube. Point 1 is the far away from the tube. So the diagram which helpful to acquire some knowledge at all. So pitot tube, it's based on Bernoulli's equation. We can use the equations, the applying Bernoulli's equation at section 1 and 2, pressure head P1 by rho g plus V1 square by 2g plus z. Likewise, we can use both sections, section 1 and 2. So the pressure by that is P by rho g. So this is the pressure head, both section 1 and 2. Whereas in section 1 it's specified by the system 1. So wherever we are using 1 in terms, that is called inlet or initial portion of the fluid. Then if we use 2 means it specifies the final point of the flow. That should be ensured first. So P1 by rho g pressure head at section 1. So P2 by rho g pressure head section 2. Then so head should be ensured the theoretical velocity, actual velocity. So actual velocity is equal to Cv into root of 2gh. Then momentum equation. So it's based on the conservation of momentum or momentum principle, which states that the net force acting on the fluid mass is equal to change in momentum of the flow per unit time in that direction. That is the Newton's second law here. So force is equal to ma. So area is equal to dv by dt, change in velocity by change in time. So F is equal to m, the A may be replaced dv by dt. dv by dt. We can simply write F is equal to d into m into v by dt. So we have to make them left side, so force into dt, that's equal to d into mv, is known as the impulse momentum equation. Impulse momentum equation. The impulse momentum equation is used, the impulse momentum equation is used to determine the resultant force exerted by the flowing fluid in a pipe end. Especially we use pitot tube in a pipe end. Likewise, momentum equation also we use in pipe end. Okay, so what are the resultant forces happening in a bent pipe? So we have to ensure the momentum equation. With the momentum equation, we can acquire more knowledge. So momentum plays a major role in the rate of flow of bent pipes. So that is very essential and need to analyze much better than the normal pipe or a straight line pipe. So the bending means the direction will be changed, and due to the direction of fluid, it have some eddy formation also occurs. That should be avoided. So to avoid such things, what we have to do is we have to provide the situation like this. That's why we, due to generation of eddy, it will affect the bend of the pipe. So where it will turn its direction of fluid flow, that get disturbed much. That's why in our early days we are using GI pipe, GI material for in bends and T's and joints. We use only GI pipe, GI based components. So why we are using GI means it can withstand the eddy affected areas. So eddy, it forcefully impact that area, it get disturbed or it have worn it very easily. So it should be avoided. So far we have to replace with galvanized material, galvanized and GI material instantly. So these are the main things here. This is the momentum equation, especially momentum equation utilized in bent pipes.